Bonjour à tous. Donc on va voir une conférence d'Éric Lafortune qui va être donc sur ProGuard, produit assez bien connu dans le monde Linux, qui a été porté sur Android. C'est une conférence en anglais, so now I'll switch in English. Thanks Eric for coming aboard in Paris for this conference. Perhaps you can introduce yourself at the beginning of the company, what you're doing, where you come from, and present you ProGuard on Android. Thank you.
Thank you. Oui, donc, malgré mon nom, je suis néerlandophone et la solution belge est que je vous parle en anglais. So I will talk about my open source project, ProGuard, which is the obfuscator and optimizer that's included in the Android SDK. So you may have heard about it, or you may even have used it before. In this presentation, I will introduce ProGuard, tell you what it does, why it might be useful for you, give you some practical tips if you're using it in real life, and I'll also talk about a little bit of the internals of ProGuard, try to explain what I find fascinating about it, why I enjoy working on it. And finally, I'll introduce the startup Psychoa that we've founded as a result of this years of work on ProGuard. So maybe a few words about myself. I'm a scientist, I'm a researcher and an engineer, but maybe more importantly, I've always been interested in low-level aspects of programming as well. So in my spare time, I've always worked with processors with limited resources, starting many years ago with a system that only had 4K of memory, and then moving on to the early ARM processors, and then later on Java bytecode, and then more recently Delphic bytecode. And the thing that I've always enjoyed is trying to squeeze the most out of limited systems with limited resources. And that also led me to developing ProGuard. So ProGuard is my open source project. It's released under the GPL, the GNU public license. And it's a shrinking, optimizing, and obfuscating program. I'll explain all of those individual steps in more detail later on. But the idea is that it takes bytecode, Java bytecode of your program, processes that code, it makes it more compact, more efficient, and gives it back to you. And it's working on Java bytecode, and it's generic, which means that it's not really intended for Android only. It also works for Java programs in general, and it has a long history in that field also. So maybe a little bit about that history. I started working on it in 2002 and put it on SourceForge. And if you have an open source project, you might know the excitement of having your first download somewhere in the world. Someone is using your program. And it gradually became more and more successful over the years. So initially it was used for applets, which was important in those days, that the applets were compact and also maybe that they were more difficult to reverse engineer. And then later on, midlets came along, which were those Java applications running on smartphones. And again, it became very important that they were compact because they had very, very limited resources. And then more recently, it has been used for, and is being used for Android applications. And that really took a turn there because in 2010, you may remember that Google introduced its license verification library, which is a library that is intended to verify if an application is licensed from the Android market. And just a couple of days or maybe weeks after that library was released, it was already cracked, and that gave a little bit of a stir on the internet. And then quite soon after that, Google recommended to use ProGuard to protect that library inside the applications of that are released on the market. And then just a couple of months later, in December 2010, ProGuard actually became part of the Android SDK, so that every developer could very easily use ProGuard. It's completely integrated in the SDK. So initially it was just a couple of downloads every month, maybe. Later on, it became something like 8,000 downloads a month. But now, as part of the Android SDK, it might be downloaded thousands or maybe tens of thousands times every day. And the success over the years has led us to create a startup, Psycho, which I'll introduce at the end of my talk. So what does ProGuard bring to you as an application developer? Well, I'll go into some detail on these items. It reduces the application size. It can improve performance. It can remove, if you want to, logging, debugging, and testing code. And it can improve battery life a little bit. And it is most popular, I guess, also for improving protection of the applications against piracy, hacking, cracking, all those kinds of things. Starting with application size, I've done a couple of tests for this presentation, taking just the API demos. If you just compile that code without using ProGuard, you get bytecode that's this size in the classes.dex file, so that's just purely the Dalvik bytecode. If you apply ProGuard in your build process, you get that size. That's a reduction of 33%. And that's a fairly typical value for ordinary applications that don't have many external dependencies, that don't rely on libraries. Of course, the classes.dex file, the Dalvik bytecode, is just a part of your application. It's all packaged in an APK file. If you look at the entire APK file, including all the external resources which aren't touched by ProGuard, then you might get a reduction of 4%, which is just limited. It's very modest. Another test, which I haven't done myself, but which has Stéphane Michelou has done and presented on the internet somewhere. He took the API demos, but written in Scala. And in that case, you don't have just the Scala code, but you also have the entire Scala runtime along with it. So that's a huge library that comes together with your application. And if you would try to generate a classes.dex file of that, you might end up with a classes.dex file of approximately 6 megabytes. But this file was so large that the DX compiler didn't even manage to create that file. So this is just an estimate of mine. But if you apply ProGuard to the code before giving it to the DEX compiler, you get something that's approximately the same size as the original API demos. So that's quite nice to know. You can use Scala, which isn't possible without ProGuard, and then even end up with something that's roughly the same order of magnitude in size as the original API demos. And that gives you a reduction of 90% in that case. And if you look at the APK size, it's still a reduction of 70%, which is quite nice. So these are two different use cases. One is a simple traditional application. One is an application that uses a large runtime library. So if you have applications with libraries, external libraries, and you're only using small parts of those libraries, then ProGuard can help a lot by just throwing away all the things that aren't needed in that code and just creating an end result that's a lot smaller. Performance then. For this presentation, I've run Caffeine Mark, which is a fairly old benchmark in general for Java and also for C code. It has a number of components in it, but it gives you an overall score, and the higher the value, the better. And in this case, it gave an improvement of 18% on one device, but it's fairly typical across devices and across different versions of Android. Something to note here, it's a nice improvement. It's nothing to throw away. But this is a result that you would get for applications that are computationally intensive. ProGuard works on the Delphic bytecode, or on the bytecode before the Delphic bytecode. And if you do a lot of work in that code, then you get an improvement. If, on the other hand, your code just relies on GPU code, or maybe it's just a GUI application, then the speed up won't be that important because ProGuard doesn't touch that part of your application. And then battery life. I'm just adding this because I got some feedback from a user just last week. He got a 5 times better battery life in his application. And this isn't typical at all, so I wouldn't count on it for your application. But apparently his application was using so much logging code, and it was a service that was running in the background. And ProGuard is able to remove logging code, and by doing that, it just increased the battery life a lot. So maybe the more important lesson here to be learned is that you don't want to log too much if you have long-running applications, or too verbosely. So hopefully you're convinced now that ProGuard can do something for your code. Well, how do you enable it? That's quite simple. It's all prepared inside the Android SDK. If you set up a project, you'll get a project.properties file, and inside that file there is already a line that you simply have to comment in. It's commented out by default, but you simply have to remove that single character and ProGuard will be enabled. ProGuard isn't enabled by default because the result of this is that your application becomes a lot more difficult to understand and to debug, so that's probably not something you want while you're starting to develop. It's only applied to release versions, so if you build a debug version, ProGuard won't be applied to it. Similarly, if you build a library, ProGuard won't be applied to the library. It's just in the final release stage that ProGuard will be applied. Also, if you're using Eclipse, it's only applied if you export the application, not during regular development. What happens internally if you've enabled that flag? This is the diagram that you can find in the Android documentation. You start from source code, it goes through the Java compiler, you get class files, and normally that goes to the DEX compiler, which produces the DEX files, the classes.dex file. If you enable ProGuard, that's inserted in between. It's invisible to you. It just happens transparently. And ProGuard will take the original class files and create new class files that are optimized. And those will then go to the DEX file, DEX compiler, and so on. Now, maybe a little bit about the internals of ProGuard. What does it do to your code? What kind of stuff is happening inside? The first step is shrinking, and then later on there will be optimization and obfuscation. Shrinking is sometimes called tree shaking, and I think that's a nice visual analog where you can think of your code as a tree, and it has lots of branches and leaves, but it also has dead branches and dead leaves. And tree shaking is just taking the trunk of the tree, shaking it thoroughly, and all the dead branches and leaves will come falling out, and you'll end up with a nice live tree that contains the essence of it, what you want to have. And the same is happening to your code then. Suppose that you have lots of classes and libraries maybe, and they all depend on each other, or maybe not all of them, but most of them do. There's some class hierarchy, there are some dependencies that classes call other classes, refer to other classes, refer to their fields. And what happens then is that ProGuard will take your application, it will shake it heavily, and all the unused classes will fall out, all the methods in the classes that aren't used, all the fields in the classes that aren't used, they're all removed, and you end up with the essential application that you actually are writing. So all the ballast will be removed. the application still might not look pretty. It will essentially still be the same. The execution of the inside the application will also remain the same. It's just that all the cruft has been removed from the application. An important aspect here is that where do you hold the application? Where does ProGuard hold the application when it's shaking this application? And those are the entry points. Because if you just give an application to ProGuard and you say, well, shrink it, ProGuard will shrink it down to 0 bytes. You'll have a perfect application, but it won't do a thing. So what you have to define is the entry points in your application. And for that, ProGuard has configuration options. They're called typically keep options. And then there's some Java-like syntax to specify which parts of your application are entry points that ProGuard shouldn't throw away. In this case, for instance, it says keep all the public classes with a wildcard. I don't care about the name, but all the classes that extend the activity class, and so on for application classes, services, and so on. Now, this is the easy part because the Android SDK will already do that for you. There is a default configuration, and in recent versions of the Android SDK, there is even a customized configuration file that's written out without you having to do anything for it. So this all happens automatically. That's easy. It becomes a little bit more difficult if you are using code that uses introspection, and that's the same problem with any static analysis. Because if you're using introspection and dynamic programming, there might be parts of your code that are actually used, but it's not that obvious just by statically looking at the code, because names of classes, names of methods, names of fields might be retrieved from configuration files or from other sources. And using just static analysis, it's impossible to know in advance which classes, fields, and methods those might be. And then you'll explicitly have to tell ProGuard that it doesn't, that it shouldn't or mustn't throw away those classes, fields, and methods. And it shouldn't even remove them or optimize them or rename them in any way. A simple example is in the Google license verification library, where you have to specify that you want to keep some internal interface, because throwing that away or renaming it would actually cripple the program. It wouldn't work anymore. I have some more examples. This is a pretty obscure example. It doesn't really matter here, but you can specify to ProGuard that it shouldn't, in this case, remove or rename those fields. And this is a very Java-like syntax, but the point is that you should know about your application, how it uses introspection. And maybe the difficult part is ProGuard is also processing your libraries together with your application, so you should have that same information about your libraries. If your libraries use introspection, then you should specify the same types of configuration there. As time goes by, more and more libraries are providing that information and are providing some hints that you should insert something in your configuration file to properly process using ProGuard. This is an even more complex or advanced example where you want to process juice or robo-juice, which is heavily based on introspection. It's all possible with ProGuard with the proper configuration. For instance, saying that you want to keep all the fields that have some inject annotation, or you want to keep all the methods that have the observes annotation. A very practical tip. This is the #1 issue that comes up on forums and on Stack Overflow. ProGuard is built on a closed world assumption. So just like a compiler, an optimizing compiler, it has to know about all the dependencies of your program and all the dependencies of your library. So suppose that you want to compile your program and all its libraries in one go. If there are any dependencies missing, the compiler will just refuse to compile and say, well, some clause is missing, I can't go on here. ProGuard does the same, but it allows you to add some leeway. It allows you to add some exceptions to where you know that it's not quite right, the setup of your application, but you know that the application runs. So you can just tell ProGuard to continue anyway, even though something is wrong. And these are two examples that I got from Stack Overflow, so from users of ProGuard. One user had a warning that Twitter, the library, seems to be relying on the logger library from Apache and also the logger library from SLF4J. And those weren't in his project, so ProGuard is complaining about it. But if you know that the debug build works fine, you've tested it, then apparently those libraries aren't really used in your application, and you can just tell ProGuard that it's okay. Just go ahead with it. Hopefully everything will run correctly. So this is something you can typically do in the Android environment. If you're developing outside of Android, you often have to add libraries. It's just a warning that you've probably forgotten to add a library in your input. Okay, so that was the shrinking part, which I talked about a moment ago. The second step that ProGuard applies is optimization. And just like in an optimizing compiler, there are lots of optimizations supported. I'll talk about a few. There are ones that I won't go into, but a few of the interesting ones, I'll show you some examples of them. That code elimination is the easiest one to understand, I guess. It's just like shrinking on a class level where you throw away classes that aren't used. You can do the same thing at an instruction level, where you where ProGuard can analyze instructions in the applications that aren't used and just remove them from the code. This is a simple one where a debug flag is defined, set to false. Later on, it's being used in the application. And as you can easily see, all of this code isn't necessary. It's not used. So ProGuard will remove it for you. Something to note here, maybe as a small tip, if you put final in front of this declaration, then the compiler will already remove the code for you. So the compiler has very limited optimizations, just JAVAC, the standard compiler. But that's one of them. If you have a final flag, then it will remove the code that's associated with it. Also note that I'm showing source code here, but ProGuard is of course working on the bytecode, but that's a lot less readable. I'm just showing what it would look like if you would do the same thing to source code. Another optimization is constant propagation. For instance, if you define some constant in your method, maybe directly, as I've done here, but might also be indirectly, and you're later on using them, then ProGuard can propagate those constants. So replace this code by this code, and it can then also see that it's just a constant expression and replace that by the final answer, which we all know is 42. That was an example performing the optimization inside a method, but ProGuard can also apply that optimization across methods. For instance, suppose that you have an invocation of that method with two constant parameters, and the method is quite simple again. It performs the same multiplication. What ProGuard then does internally is, in the first step, see that there is a single invocation of this method. So those values are always constant. They're always 6 and 7. In the next step, it will actually evaluate that expression And it will also remove the parameters because they're no longer used. So if there are any constant or unused parameters, they will disappear from the code so that it becomes more efficient. And in this case, it can go further than that because at this point it knows that not only the input is constant, but also the return value is constant. So it will inline the result value inside the invocation. And at that point, it knows that this method is no longer called, and it can throw away the entire method. It can also inline methods. We've seen this morning that dexopt does some method inlining also, but ProGuard can also do that. And the advantage then is that if you've inlined methods, ProGuard might take advantage of the new structure of the code to perform other optimizations. This is a simple example. It's a very short method. ProGuard will then say, well, it's short enough. I'll inline it, and it will perform all the necessary modifications to inline it properly. And at that point, it will say, this method is no longer being called. I can just throw it away. It happens for short methods, but also for methods that are only invoked once. Of course, there are lots of constraints. There are cases where you can't inline methods because, for instance, if this is a method that extends a method in another class, it's not all that simple anymore to just inline it because you might change the functioning of the program. So there's, I think, about a page of code with conditions on which you can inline or can't inline a method. There might be side effects due to static initializers, all those kinds of subtleties that define that. A somewhat special optimization, which you won't find in traditional optimizing compilers, because ProGuard is working on class files. It can also merge class files. And under some conditions, for instance, it'll take away or take together, combine together, two class files into a single class file. That way, saving a little bit of space in the program, making it a little bit smaller again. There are lots of conditions where you might want to do that, or even more conditions where you don't want to do that. I think there are 2 pages of code dedicated to cases where you can't merge classes. For instance, you don't want to introduce additional fields in a class because that would increase the size of the program at runtime, even though the code might be smaller, the size of the code, the size of the application at runtime would be larger. This is what I call horizontal merging. There is also vertical merging. So in some cases, you might be able to take together 2 classes in the class hierarchy vertically. And a typical application here is that you have an interface A and just a single implementation class B. And then you could just throw away interface A and work with class B in your code. And ProGuard will do that for you by merging them and changing all the references in the code. And that gives you a modest performance gain as well. And then just my last optimization example with some code. It's my favorite. It's test number 544 in my series of tests. And it shows tail recursion simplification. So it's a bit similar to the previous example. There is a single invocation of a method, and that invocation has a number of constant arguments. And then internally something is done with those arguments. It's pretty hard to follow what happens, but there's a tail recursive invocation of that method again with different arguments. So some combination of the arguments, and they're shifted in some way. Now in this case, ProGuard can't inline those constant arguments because there's a second invocation which has those different arguments. But what it will do is simplify the tail recursion first. So every tail recursion like this can be replaced by a while loop, an infinite while loop. And there is an exit still at this point. So this code is equivalent to this code. I've noticed here that I've put this while loop on the wrong line. It should actually be here. It's still very hard to see what it does, but at least the recursion is gone. So, yeah, sure.
Is there an impact on your optimization if we put final on the arguments of the function?
If you put final, no. So you mean in this location? No. Final is actually in that case only used as an indication for the compiler. That flag is nowhere to be found anymore in the bytecode. So ProGuard wouldn't even see it. So the code has become simpler, and in this case you'll get an improvement because there is no longer those recursive calls with all the stack manipulations that come along with it. And also because of this optimization, ProGuard can start inlining those constant parameters that we had there. So all of a sudden this has become the sole invocation of this method. Those parameters can be inlined, and then ProGuard does the necessary control flow analysis and data flow analysis inside this method. It does some simulation of what happens to the code, and the end result of it is that it knows that the answer is 42, and it will inline that in the invocation, and it will remove the code altogether. So this is actually, this was a kind of a turning point for me, because this is a place where ProGuard surprised me by what it could do. I was testing the code, and all of a sudden my code was gone. And that was just because it had found the final answer and filled that in the output. So how do you enable optimization? I've showed you how to enable ProGuard earlier, but in recent versions of the Android SDK, that doesn't enable optimization as well. For that, you have to point this property to a slightly different file with the optimize word in it, so that it uses this different configuration which enables the optimization. I guess the Android team is doing this because it wants to play on the safe side. The optimization part of ProGuard is by far the most complex one, and especially in the past there have been bugs in it which of course annoy or block users. So just to play safe, it might be better to disable optimization by default. But still I find it a nice property, and it helps to create better applications. So I always work with optimization. Also, maybe a lesson here is that if you run into any problems with the optimization, it might be worthwhile to look on the ProGuard side, see if there is a more recent version of it. And you can then just take that ProGuard jar and install it inside the Android SDK. And ProGuard is always backward compatible, so just switching out jars is sufficient to upgrade to a new version. One final aspect of optimization is that you can use ProGuard to remove your logging code. And this is the type of configuration that you want to give for that. You say, or you tell ProGuard that some methods don't have side effects, the logging methods in this case. Now that's not actually true, because they do have side effects. They print out something to the log. But if you tell ProGuard that, it will just believe you, and it will remove all the invocations of those methods. And you'll end up with an application again that's shorter and doesn't contain any of your maybe debugging code. You can do similar things for other methods, but you have to be careful not to disable essential parts of your application, because then it won't work anymore. Okay, so that was shrinking, then optimization, and the final step that ProGuard performs is obfuscation. And this is traditional name obfuscation, which means that it replaces the names of classes, fields, and methods by short, meaningless names. And in addition, it removes debug information that's not essential for the execution of the code. For instance, it removes line numbers, unless you want to keep line numbers. It removes local variable names, and so on. Those aren't necessary for the execution of the code. Yeah.
Does that mean it doesn't merge packages?
It can also merge packages, yes. So it can put all of the classes into a single package or into the root package so that you don't have packages at all anymore. That's an option. It's not enabled by default because that might actually change the working of the program if you rely on resource files being available in some package or something like that. This is a simple example of a class that's being obfuscated. You start out with classes that have meaningful names. The fields have meaningful names. The field types have meaningful names, methods. And after ProGuard has worked on it, you just have a class that's a lot smaller and also more difficult to understand. Now, depending on your point of view, that might actually be desirable or not. But at least the fact that the application is smaller is something that's universally a nice thing to have, I think. Now, I sometimes get questions about why do I have an open source obfuscator? Why go against the grain of the open source spirit? Well, I think optimization and obfuscation are intertwined, really. So for instance, optimization is also some kind of obfuscation. You start with an application that's nicely structured. You might have nice layers of classes with different responsibilities. Inside those classes, you might have methods with their own responsibilities. And the optimizations that will just take that code and squash it and mangle it, and it will still be the same code, but the design might be gone entirely. Also, the other way around, obfuscation is some kind of optimization because it takes all those long names, those long identifiers, and it makes them shorter and makes more compact program. And you can also say about both steps that they irreversibly remove information from the code. They just try to bring it down to the essence of the code. Okay, before I tell something about the startup, I'll point you to a few sources of information about ProGuard. First of all, there's the information that Google provides inside the Android SDK, inside the documentation, which you can find, of course, at that location. If that information isn't enough, there's the ProGuard site itself at SourceForge, which has lots more information. Especially if you run into any problems, there's quite a nice manual inside. And especially inside that manual, there's a troubleshooting section. So this is built, all those years based on feedback from users, all the comments that I've received. I've tried to collect all the problem cases that users might bump into and try to provide a solution in the troubleshooting section. This documentation is also inside the Android SDK, inside the ProGuard directory. So you can't find it from the Android documentation itself, but it's present in the distribution as well. Okay, maybe a few words about the startup. ProGuard has become quite a success everywhere. So we've started a startup around it. And the first thing we do is still maintain ProGuard. So in the past, I could work on it at night. Now I can work on it in the daytime and at night. Of course, ProGuard is still released under the GPL. It's still open source. So we don't make any money on it that way, except for companies who might need an exception to the GPL for their own use of ProGuard inside their larger systems. Secondly, we provide services. If professional companies might need some assistance setting up ProGuard, configuring it so that it optimally processes their application, we provide support for that. And finally, we have a product out, just released in May, June, which is DexGuard. And I'll just say a couple of words about DexGuard. I told you about ProGuard in the beginning. Well, DexGuard is a specialized version of ProGuard based on the same technology that focuses more on application protection. So this is one of the important reasons why many developers are using ProGuard already. They are concerned about piracy and about hacking and cracking. And as much as I like the optimization part of ProGuard, in real life, this is something that many users are concerned about. So it puts a focus on protection, and it's also specialized for Android instead of being generic for Java bytecode. And because of the protection measures that are inside of it, it's also necessarily closed source because we can't give away all the techniques that we are using. But it's still compatible with what ProGuard does. Maybe a difference also is that it writes out Delphic bytecode instead of Java bytecode. So it does all these different steps that I showed in the beginning just in a single step. There are lots of reasons to be afraid for developers of apps who want to make some money with it. I won't go into them. There are some legitimate uses of hacking or applications of hacking, like anti-malware research, but it quickly deteriorates into some grisly applications. So I get some pretty bad horror stories from users and customers. There are some solutions to that. You can just ignore it, which is a very Zen-like approach. You can take a different business model, and that's very applicable here, of course. You can just open source your application and try to make some money on it in a different way. Some other techniques, if you can lock down the device, which is an option we typically don't have with Android, you can do some more. You can run code on the server. And what we're mainly trying to do with DexGuard is to go further in the obfuscation and the application protection direction. I won't discuss these techniques in detail, but these are the ones that are typically used, and that DexGuard applies automatically, so you don't have to do that yourself. You just have to specify what you want to do to your application where, and just like with ProGuard, it takes your application and processes it and comes out with a better and more hardened application in this case. If you're interested in that, I'll gladly point you to our website, psychoa.com. But you can also talk to me later on. But for now, this is the end of my talk, and if you have any remaining questions, I'll be happy to take them.
Thank you for this presentation. Anyone have a question in English?
Ou en français.
Hello, suppose that I deploy application on Google Play, and after I have some traces from user that say it's not working. Could I reverse this trace to make the more understandable?
Yes. So the stack trace that you would typically get out of an application that has been run through ProGuard will contain lots of A's and B's, and you typically won't be able to make sense of it anymore. So there's an accompanying small application called retrace, and you can put your stack trace through retrace and get the original stack trace back. And that's based on the information that ProGuard can write out all the mappings between the original names of the classes and the new names, the original names of the methods and fields and the new names. So that's something you as a developer can do. Yes. Retrace, yes.
Yes, right.
It's inside the ProGuard distribution, so it's easy to find. It's also documented.
Right. Is there a tool to have kind of preview of what we could expect from running a ProGuard?
Not really.
Some stats about
There are statistics, yes. If there's a verbose flag to ProGuard, and then it will print out a summary of about a page about all the optimizations that it has performed. There is also logging about all the fields and methods and classes that it has removed. That's another option. There are no details about individual optimizations because, as I've shown here, there are often optimizations that are only executed after a lot of other optimizations have worked. And that's very difficult to explain to a user that, well, after 5 passes of optimizations, I've still been able to do this optimization. So there are no details. It's just at the level of statistics that something that you get.
I didn't quite catch the slide when you presented when you run before the DEX tool?
Yes, before. So
there's no overlap with the DEX optimization?
No. DEX will still perform its own optimizations. Well, probably DEX won't do much. DEX opt might do a little bit on the device itself. But there is no overlap. It's just inserted in between the compilation step with Java and the conversion step with DEX.
You have mentioned in one slide about the encryption of different objects, items.
Yeah.
I suppose that at the execution time, you decrypt, of course, in order to make it happen.
Yeah.
So there is some kind of overhead associated with that.
Yeah.
And secondly is that's good. Class encryption is what is that? I cannot catch it.
Okay.
That's the question.
Those are features of DexGuard only. String encryption and class encryption, they're actually bad names that are typically used. It's more like string obfuscation because you can encrypt the string in your application, but by definition you will need it later on when you're running the application. So you will need to decrypt it, and that information is inside the application already. So it's an obfuscated way of putting your strings in the application.
Okay, well,
and there is some...
String, there are two things. It's the label and the content. It's the pointer and which is transformed into a pointer.
Yeah, I'm talking about the content here.
And the content, of course,
Yeah.
you encrypt the content.
Yeah. So if you have a string that defines some secret key,
Okay,
or
so that means the content of a class, which is an area of memory, is encrypted and is decrypted at runtime.
at runtime when it's needed, yes.
With a key that is defined by who? By ProGuard?
That's chosen by DexGuard internally, so it will do something for you. Yeah.
Okay, thank you.
And it's randomized and all that to make it
So it's Dex.
more secure.
You said that program can inline some methods if they are short. Or
Yeah.
can you force? Let's say there's a method I think I'm smarter than ProGuard and I think I want to inline it for some reason. Can I force that?
No, there is no way to force it. There are so many users, and I try to protect users from doing any stupid things, because if I don't do that, I get lots of bug reports because they've tried silly things, and I have to explain them that that's not possible. So I'm always working on the conservative side, on the safe side there. If the inlining doesn't happen as you would hope, I guess the only solution at this point is to look at your code and maybe look at the ProGuard code, all the kinds of conditions that it has, because it doesn't provide feedback on why it doesn't do anything there. And that can be pretty complex. So a typical example is that there might be static code in a class that contains a method, and that method then can't be inlined often. Sometimes it can, but often it can't in another class, because then that static initializer wouldn't be called anymore. Sometimes that's okay, sometimes it's not, and I just have to be on the safe side there and not inline the method.
I have an application that has been encrypted with ProGuard, and sometimes when a customer falls upon a bug, he sends me the log file, and of course it's the methods and the class names are encrypted.
Obfuscated, yes.
So I use the map files, which give the mapping between the obfuscated class name and the original class name. So is there an easier way to try to understand where the bug comes from?
An easier way. I guess part of the intention is to make it difficult to.
From my side.
From your side, yes. Well, right now retrace is just a small command line tool. You provide the original or the obfuscated stack trace, and you get the deobfuscated stack trace out of it. You could integrate that tool into a GUI or something, or well, it's even integrated in the ProGuard GUI as well. But you could integrate it in your process where you receive feedback from customers. For instance, I know there are sites online that collect stack traces and error reports for third-party applications, and they have a feature to support ProGuard automatically, to support deobfuscation automatically. So in your process of receiving feedback, you could automate something, I guess, but that's outside of my area, I guess.
You enable logging. It's simple. If there is a bug, you recompile, and you enable or you disable. Well, you have an option there in order to exclude.
Yes, yeah.
So that's it. I mean, re-enable the logging, and that's it.
Yeah, but that might be hard if your application is already out there and crashing.
If it's a functional matter, of course you cannot do that.
Yeah, yeah.
Thank you very much.
You're welcome.
So, switch in French. On se laisse une petite pause de 5 minutes avant la prochaine conférence sur Understate par Sylvain. Et si ça vous intéresse, on a une personne ici qui travaille chez Arcos et qui vient d'amener la dernière tablette, je ne sais pas si elle est sortie dans le commerce, c'est la fameuse tablette, si, d'accord. Donc voilà, qui est aimantée, là, qui se tourne. Voilà, il va nous faire vous fera une petite démo pendant 5 minutes. Voilà. Thank you very much. Huh?
You're welcome. It was okay.
It was perfect. Thank you.
I'm not a mathematician, but I'm wondering, is this way of optimization, obfuscation, it's easier when you work in bytecode if you use it? Because what you do, it's refactoring, which is like you have to sit down and really like think about it. But in bytes, it's like you see it, right?
Yeah, in
Okay,
bytecode.
that's what I thought.
And bytecode is a lot easier also than source code, because bytecode is very nicely structured, so it's easier to work with.